Okay, in this video, continuing with more Cisco ONS 15454 DWDM configuration guide. Here I'm moving off into chapter 10, what we'll do in this chapter is look at what are called Rotoms. Okay, this is a reconfigurable optical add-drop multiplexer card, as opposed to the fixed OADMs from chapter 9. Okay. And the Rotoms are really the big thing. This is what I used to work on when I was at JDS Uniphase. This was about 10 or 12 years ago now, and the Rotoms were the big and up and coming thing. And I'll show you some of the block diagrams of these devices that I happen to be extremely familiar with from a previous life. Okay, so in this chapter there's a whole bunch of Rotom cards, and I'll give you the summary here. The 32WSS, the 32WSSL-L. So the normal one will work in the C band, the -L will work in the L band. Okay, WSS stands for wavelength selective switch. Okay, and then there's a whole other page here of different cards in this series. We got the 32DMX, DMX stands for DMUX, 32DMXL, DMUX in the L band. We've got the 40DMX in the C-C for the C band. We've got the 40DMX-CE. We've got the 40MUX-C. We've got the 40 wavelength selective switch C, the 40 wavelength, the 40WSSCE. And then we get on to some real fancy ones. The 40WXC. WXC stands for wavelength cross connect, and this is the most flexible type of wavelength switching that we have these days. Finally, the SMR1 and the SMR2. I'm not sure I'm going to get to talk about all these things. And then finally, the MMU is sort of the ultimate card in this series, and let's see, I'm not sure I'm going to talk about all of these cards, but we'll talk about a few of them in chapter 10 here. So let's look at a couple block diagrams. Here's the 32WSS block diagram. This is the block diagram that I am very familiar with. We used to make these things. And it's two AWGs back to back. First you demux them, separate all the channels out, and then you bring them all back together again. But in between, you allow for adding of channels. Okay, and so you've got an optical switch here. And now once you're in between these AWGs, each fiber or each line contains only one wavelength. And so you can have a 1x2 switch here that allows you either to pass that channel through and then remultiplex it back into the signal, or instead of taking the pass-through channel, add a new signal in at that wavelength. And the add ports are wavelength specific here because they are associated on a one-to-one basis with the outputs of the DMUX. That's important. Each of these cards has both a transmit and a receive section. On the transmit section, we are allowed to add channels. And on the receive section, well, it's just the other part of it. This is where we drop them. Okay, and basically, you have an optical splitter that allows you to send all of the channels out what's called the express port, the express transmission port, and then again all of the channels go out the drop transmission port. And what you're going to do then is you're going to send the drops to another demultiplexer, a 32DMX, and that way you can separate out, and only those wavelengths that you want to drop do you take. And then the express channels, it says the express transmit port goes to the 32WSS. And this is the 32 WSS. So basically this one is looped back around. Okay, so you drop the channels and then you add channels. Okay, that's the idea. And this is, you know, it's a pretty sophisticated device. There's a VOA for every channel. There are optical photodiodes, 2 of them on every channel to monitor power. Okay, here's what the faceplate of the 40 DMX looks like. Okay, let's see, what is the 40? This is just a demultiplexer, I think. Yeah. Here's another block diagram I wanted to show you, which is the 40 channel wavelength selective switch module. And it's basically the same as the 32 channel wavelength selective switch with 2 back-to-back AWGs, and then on the drop side you just drop the whole thing and send it off to a demux. Finally, the other one I want to talk about is the WXC. This is the wavelength cross connect, and this is sort of the fanciest version of any of this stuff, where we have essentially an optical switching fabric here, okay, that allows us to map any input to any output. Okay, so this is a very sophisticated device. It allows us to drop channels in the same way we've seen before, where we just have a splitter and we just send all of our channels out on that drop channel and let a demux separate them back out. And whichever ones we want to drop, we just take. On the add side, though, we've got this wavelength cross connect, and this gives us a lot of flexibility because it decouples the wavelength from the port. Remember, on these devices, each of these add ports was tied to a particular wavelength because they were hardwired in or connected by fiber to a particular channel in between the AWG demultiplexer and the AWG multiplexer. So there were wavelength specific add channels. These add channels are not wavelength specific, and they can be mapped to any one of the wavelengths. I'm not going to go through all of this detail here, but that's the idea of this one. So it's much more expensive, but you get all that functionality. And these add ports are then called colorless add ports when they are not tied to a particular wavelength. Okay, that's all I'm going to go over on that chapter. As I say, there's an awful lot of these things here. There's demuxes and muxes, wavelength selective switches, wavelength cross connects, the MMU. I'm not even going to go into all of these things, just showing you the basic idea here of the optical the Rotom cards. Okay, thanks.